of lifetime, which is T off, or in some textbooks they take it as T 50%. So it is off lifetime. Let us discuss this off lifetime with an example. Let us see what is this off lifetime. Students, let us consider a reaction in which the reactant A is converting into product P. A simple example. So, initially, in the beginning, let us take time t as 0. When time t is taken as 0, the initial concentration of the reactant A, let it be 100 grams. And we know that as the reaction proceeds, slowly the reactant A is converting into product P. As the reaction proceeds, as the time changes, say after 5 minutes, let us measure the concentration of reactant A, students. Let us take some example here. Let the concentration of the reactant A, let it be 50 grams. So there is decrease in the concentration of reactant A as the time progresses. What is happening to the amount of reactant which I have taken initially? The reactant is slowly converting into product P. Hence, the concentration of product P, I take it as 50 grams because initially 100 grams I have taken, 50 grams of reactant has been converted into product. So, now I take this particular time as off lifetime. Now I will define off lifetime. It is the time required for the reactant molecule to get reduced to half of its initial value. The initial concentration of reactant A is found to be 100 grams. From 100 grams, the reactant A is slowly converting into 50 grams, half of it. So, for the change in the concentration from 100 grams to 50 grams, what is the time consumed? That time we call it as off lifetime. Off lifetime is the time required for the reactant molecule to get reduced to half of its initial value. A very important concept. So, usually off lifetime, we take it as to calculate off lifetime. So, we take the equation off lifetime will be equal to 0.693 by K. A very important equation, students. Again, this is another important formula from which you can get many problems in your examinations. So, it is very important, this particular equation, T off will be equal to 0.693 by K. So, whatever the equations which I have derived, so in your competitive examination, nobody will ask you the derivation of those chemical equations, but remembering the final equations, substituting the correct values, that is very important. So, 3 equations are derived, and this is with respect to the off lifetime. Those are integrated rate equation. What is off lifetime? It is the time required for the initial concentration to get reduced to half of its initial value. So, now in today's class, let us see how off lifetime and initial concentration of the reactants are related to each other for first order and zero order reaction.